All right, here is our last video, and this is where it gets a little more 8th grade in terms of the inequalities that we're solving. This is called solving multi-step inequalities. And again, this is the same set of notes. You can just kind of continue on. You can write this right here as your kind of a subheading, solving multi-step inequalities. And we're just going to hop right into it here. We've already solved 2-step inequalities. Now we're moving into multi-step. And you'll see some of the ones on your worksheet from last night, especially on the back, will be similar to some of these, and some of these may be a little more advanced. I can't remember exactly, but the principle is the same. You're going to basically just keep doing the same thing we've been doing. So we're going to start with this one right here. I'm going to rewrite it over here. X plus 1 plus 4 is less than or equal to 9. Again, we're just solving these as if they're equations. And just keeping in mind, if we multiply or divide by a negative number, we have to flip the sign over to keep the inequality true. So the first thing I think about is, how am I going to, I want to get the x alone right there. So I want to get rid of the 1 and the 4 right here. So the first thing I might do is just combine those, the 1 and the 4, and we get x plus 5. And then this one becomes very, very simple. We simply subtract 5 from both sides, and we get x is less than or equal to 4. And there is our algebraic or symbolic solution set. And then let me see if I can keep that from being so wide. That looks a little better. So our graphical solution set or graph will look like this. We have 0. We have our cutoff number here. 4 will make this inequality true right here if we plug it in. So we're going to include 4 in the solution set by putting a closed point or circle on it. And then numbers that are less than 4, according to the inequality symbol, will be in this direction here, to the left of 4 on the number line. And there is the solution set to this inequality. So that one's not bad at all. Again, if you need more time, get behind the substitute can pause the video. But if it's just 1 or 2 people, we can't hold everybody up for those. I'm sorry. So let's move on to the next one in our list here. We have a total of 4. So the next one is going to be this one right here. 5k minus 2k is greater than negative 9. So if you notice, if we have 5k's here and we are going to take away 2k's, well, we have 3k's left then, right? That wasn't too bad. And that's greater than negative 9. And then to get rid of the positive 3 there, or multiply by 3, we're going to divide by 3. Now, we are dividing a negative 9 by a positive 3, but if you notice, these are positive 3's. Even if this 9 right here is negative, that does not mean we need to change the sign or flip the sign. It's just the number that we're multiplying or dividing by. And since the 3 is positive, we're simply going to keep the sign the way it was. So it'll be k is greater than negative 3. So there is our symbolic solution set. Basically, all numbers that are greater than negative 3 will make this inequality true. The graph again looks like this, and you should get better every time that we're graphing and kind of already predict what it's going to look like. So negative 3, is it going to be included in the solution set? Does negative 3 make this right here, this inequality, true? In other words, is negative 3 greater than negative 3? No. So we're going to put an open circle on it, but numbers that are greater than negative 3 will make it true. So that'll be numbers in this direction right here. And there's our graph of the solution set for this multi-step inequality. Those first two really aren't that bad, but then we start to move into some that require a little more work and definitely more care to make sure that we don't make mistakes. So moving right along here to the third one, we have negative 2 is greater than or equal to 4p plus 6 plus 4. And as you're thinking about this one, what's the first thing you notice? Well, hopefully you notice that there's a variable on the right side, so we need to rewrite this one. I would strongly suggest it. Now, you can solve it and get it correct without doing that, but it saves you such a headache if you go ahead and just rewrite it. Just from my experience, just trust me. So I'm going to rewrite it so that we have 4p first plus 6 plus 4. And if you notice, the inequality symbol here is pointing towards the 4p. So I'm going to make sure again that the point right there is pointing towards 4p plus 6 plus 4. And then on the other side, we now have -2. And then it's just a matter of trying to get the p alone. So I have 4p, 6 positives plus 4 positives is 10 positives. And then subtract 10 from both sides, or add 10 negatives, it's up to you. So 4p is less than -12, and then we're going to divide by 4. And again, just to point out, just because we're dividing by 4 and this 12 here happens to be negative, that does not mean we have to flip the sign. The 4 itself, right here and right here, those are positive. So we're not going to flip the sign. We just have p is less than -3. And there's our algebraic solution set, our graphical solution set, or graph. So we've had a lot of graphs like this where we have a negative cutoff number. In other words, we have any number that is less than 3 will make this inequality true. So 3 or -3, any number less than -3, sorry, will make this true. -3 does not make it true, but any number less than it, and that'll be numbers to the left of -3 on the number line. All right, and I'm going to move on to the very last one. Again, pause if needed. And here's our last one for the day. And there's a lot going on here, but you got to be really careful. So we have -33 minus n. Whoops. All right, there we go. Is less than or equal to -3 times 2n plus 1. And you'll notice we have variables on both sides. So at this point, there's really nothing you can do about rewriting it because you're still going to have a variable on both sides. And if you'll notice over here, we have the distributive property that we're going to have to do. All right, so I'm just going to go ahead and deal with it the way it is. The -33 and n right here, there's nothing we can do there quite yet, so I'm just going to rewrite that. But I am going to distribute -3 times 2n, which is -6n, and then -3 times 1, which is -3, and we'll write that as -3. Okay. Now I want to think about getting these n's together. Notice I have -n right here, and then -6n. So I'm going to do this. I like to get the variables on the left side if I can. So I'm going to add 6n to both sides to cancel that out, and then add 6n over here. And we get -33. We have -1n plus 6n, that gives me 5n. So now I'm kind of happy because I have the variables on the left. I didn't have to rewrite it, I just used inverse operations. All right, now I want to get the 5 positive n's alone. So I'm going to add 33 positives to this side to cancel out the 33 negatives. And over here I'm going to add 33 positives. When I do that, I get 5n is less than or equal to +30. And then divide by 5, and we get n is less than or equal to +6. So as long as you keep following the steps, step by step, and showing your work. Now, if you're the kind of person you continue to skip steps, you're never really going to find yourself being as successful at this as you could be, because you're not putting into it the work that needs to be put into it, and you're just going to get further and further behind. This just get more complicated. Our graph down at the bottom, our cutoff is 6. 6 would make this inequality true, so it is included in the solution set. We're going to give it a closed circle, and then it says numbers that are less than 6, and that'll be in the direction left of 6 on the number line. So there is our graph of the solution set. And guys, that wraps it up. So at this time, any remaining time you have at the after the videos are over, you can spend on completing the rest of the worksheet for tonight's homework, and that'll basically get you ready for the last topic you'll need to know for the NC check-in. I'm sorry I can't be there to help you review a little bit more, but let me encourage you and ask you these questions. Do you know your rules for rotating 90 degrees, 180, 270? If not, then you know what you need to study tonight to do this as good as possible on the check-in. Do you know the rule for reflecting over the x-axis and the y-axis? All right. Do you know translation notation? Do you know how to dilate a figure? All those things are in your notes. It's up to you to decide for yourself how well you want to do on the check-in. Doesn't mean you have to go home and study for an hour. Study 15 or 20 minutes. If you break it up into 10-minute increments, that's fine. But just do something to give yourself the best chance. If you want something you've never had, you got to do something you've never done. And for some of you, that is actually take time to prepare. All right. So have a good evening. And again, if you need me for anything or have any questions, just feel free to send me a message on Remind or shoot me an email. All right, guys. Thanks and have a great evening.